channel daily classes. Hope you have enjoyed my earlier videos, and today's video is also an interesting one. Today I have chosen the topic software testing. So without wasting any time, let's start the video. Now before going to software testing, we should know what is software development lifecycle model. I don't think so that it is necessary to explain, but we should see what are the different steps in any lifecycle model. In general, what are the different phases of software development lifecycle model: feasibility study, requirement analysis, design, then coding, then testing, then implementation and maintenance. So today our main interesting topic is testing. So before going to further details, why I should know why it is important. It's also a very important level, because without testing you cannot implement a software in correct manner. So let's start. What is actually testing? Software testing is the process of evaluating a system to find whether the developed software satisfies the specified user requirements or not. It finds the correctness of the testing system by matching the actual results with the expected results of the system, and to ensure that the system is bug or defect free. So main motto is to identify is there any error in the system, or whether you are fulfilling the requirement analysis of the user or not. This is the main motto, because you have to make a reliable software, user specified software, and it should be a error free and failure free. Now according to ANSI IEEE standard, which is known as ANSI IEEE 1059 standard, the software testing can be defined as a process of analyzing a software item to detect the differences between existing and required conditions, that is defect, errors, bugs, and to evaluate the features of the software item. So this is the IEEE definition of software testing. Now in next we will discuss some of the familiar terms which always comes when you are talking about software testing. The terms are, you may always come to face this type of terms. Those terms may be your bugs, then defect, errors, failures. Now what is bug? If you define a bug is nothing but any mismatch in the development system in testing phase is called as a bug. It is found by the tester. So in development phases, if the tester faces anything wrong in the developing stages, then it is known as the bug. Now what is defect? The differences between the actual results and the expected results called as defect. The developer shows the defect himself in his development phases. So suppose you are intending to design a particular process, say your intended task is A, but you are getting output as B, and this differences, when it is specified, then it is known as a defect. Then what is error? Error means unable to successfully compile or run a program, then they are called as an error. It is found by the developer itself. So what is error? Error is nothing but, suppose you have written a particular program, you are a developer, but suppose you have compiled, suppose you have written a program in C, when you are trying to compile it, you are not able to run it, then it's an error. So errors and defect sometimes use vice versa, but that is not the case. Errors are different and your defect is also different. Then failure. The failure comes at the end user is. What is failure? Once the product is deployed and reaches the customer, and if he finds any issue, then that particular issue is called as failure. So whenever you are talking about the failure, that is software failure, you can say that the customer comes into play. Customer says that he is not satisfied with his user. Suppose he is intending something and he is getting something, that means you have wrongly developed a particular software, that is known as the failure. Another important thing in software testing is that we always comes in two terms. So this verification and validation. Let us know what is verification and validation. Now verification means, are you building the right product? And this is the must. Sometimes what is happening that you are using verification and validation in vice versa. They say not same, they're different. Verification comes before validation. Now what verification means? Are you building the right product? That means this is a phase-wise computation. Suppose in your particular phase, what is going on, whether it fulfills the user requirement, desired requirement or not. Then you go for the second phase. That means whether your particular phase output confirms to the input to the second phase or not. This is verification. Now validation means are you building the product right? This is the end user. When user says that yes, he is getting the product right, he is expecting whatever he is getting, then this is a validation. That type of decision is taken by the validation process. So in details, if you go on, then let us see the definition. Verification is the process of checking whether the software implements a specific functions correctly or not. That is, whether the software conforms to the user specification or not. It is a static testing process. Why it is known as a static testing process? It is known as static testing process because here no code execution is done. That is, you are not executing the code, but you are checking by using some static processes. For example, and say you are looking at the different phases, whether the phases are okay or not. That is the verification. And once the verification is over, then you will go for the validation. Now, when verification is static, we are telling that verification is static. Now, what are the different types of strategies used to do the verification? Review techniques like code walkthrough, which we have discussed earlier. Code walkthrough, code inspections. This type of techniques are used for verification. Now, validation, we have shown that validation, are you building the right product? But that means validation is the process of checking whether a fully developed system meets the user requirements and expectations. It is a dynamic testing process. So when you are talking about the verification, it is a phase-wise computation. When you are talking a validation, then you are talking the whole system. So verification always checks whether it fulfills or meets the user requirement, the final product. It is the dynamic process. Because it is dynamic because you have to execute the code, the tester will be there, you will check each and everything, and the final product will be executed and it will be deliverable. Whether if it is acceptable, then it is deliverable. So there is a huge difference between verification and validation. Now for validation, different techniques are used, just like black box, white box testing, non-functional testing. Different techniques are used which are known as a dynamic testing because here the code will be executed. So main difference is verification and validation is that in verification code is not executed, in validation code is executed, and validation will be always done after the verification. So before the next section is that what are the different types of software testing techniques. There are different types, two mainly broad classification. One is the manual testing and other is automated testing. Manual testing means when human being interferes. Now what is manual testing? Software is tested manually. What is automated testing? Testing is done using automated tools or scripts. There are different kind of testing tools are available online, offline, like this. There are different softwares which will test automated. Manual testing is always necessary because you cannot avoid manual testing. For example, code review should be done, code walkthrough should be done, code inspection should be done. Then and online code review automate. You cannot automate all testing processes. So today I will emphasize on discussing the manual testing techniques. Now, what are the different types of manual testing techniques? One is the black box. There are many types, broadly classified into two categories: black box testing. Second one is white box testing. Now in black box testing, there are two types of strategies are used for designing test cases. One is equivalent partitioning approach. Second one is boundary value analysis. In white box, we know that there is statement coverage, branch coverage, condition coverage, part coverage. There are many others because these are the main white box strategies. So that I have taken out of these different techniques. So in today's video, I will discuss only the black box testing. So let's proceed. What is black box testing? Black box testing is a testing technique in which functionality of the software system is tested, in which tester does not have the knowledge of the structure of the internal source code and its implementation details. In black box testing, tester design test cases based on their analysis of the inputs and outputs values at the system interface only. It is also known as functional testing. So in black box testing, suppose I am doing the black box testing. I don't have any idea of whatever inside code is written, how the internal code is written, what is the structure, data structure used, how data will be executed. That is not bothered for me, because that is a black box. Internal whole system will presumed to be black box. So that's why it is also known as functional testing, because we are not considering the structure of the system. We are testing that suppose A is a function, input will be something and output will be something. That is function. That is why testing the function. A function is intended to do something, whether it is satisfying that particular intention or not. So that's why it is known as black box testing. Now there in black box, if you see the pictorial definition, the input will be there, black box will be there, on which you will be doing the testing. Black box techniques will be there, because you don't have any idea what they were inside the black box. And output will be there. So based on the input and output, you have to do, because you have the idea based on input and output. You have to design test cases to test the particular functions. Now let us take one different techniques. We know that there are two techniques. One is the equivalent class partitioning and another is the boundary value analysis. So what is equivalent class partitioning? The definition is that equivalent partitioning is a test case design technique in black box testing, in which the input of the software is divided into equivalent data classes such as valid class and invalid class. Test cases are designed for each equivalent data class. So you have the black box, you have to do input, choose input, and you have to get the output of the required result, to get the required result. Now suppose you have to do something for unknown facts, then what you can do? You have the target and you have to choose inputs. So you have to define the input domain into different partitions, and those type of partitions are known as equivalent class partition. Why it is known as equivalent class partition? Because it is not possible to test each and every input. For example, suppose you have designed a particular program to find out the factorial of a number. So it is not possible to test each and every number, because numbers are infinite. So you can say that suppose you have to number is positive, then you can design any positive number to take it in. If it works for a positive number, the system will work for whole numbers. So that's why you have to take a particular partition, that positive number and negative number. So in one particular element of that particular class will replace the whole class. So that's why it is known as an equivalent class partitioning. So you have to design the valid class, one is invalid class. That means one particular input will be valid input, other particular partition will replace the invalid input. So this is the equivalent class partitioning. So that means one particular value from one particular replaces the whole system input, for example. So let us take one example. So for example, you have to design a test suite using black box for a particular software that computes whether an integer number is even or not. The system can accept integer numbers between 50 to 500. So you have a source code for your software which will accept integer number within the range of 50 to 500, and you have to set the program is that it will set even number or number. So how you have to design the equivalent classes? So there will be three types of inputs. One input will be within the range of 50 to 500, other range will be 500 above, and other range will be less than 500. So you have to divide your input into three partitions: one less than 50, one 50 to 500, and other partition is above 500. So the solution is that we have to design three equivalent class partitions, two invalids and one valid. What is the valid class? 50 to 500. What will be the invalid class partition? Less than 50 and above 500. So in the picture you have seen that invalid partition, valid partition, and your invalid partition. So let us take one class we have defined as 47, 48, 49 is a partition 1, 50, 51, 500 is a partition 2, 50 to 500, and second is 500 to 503 and partition 3. So you can take any number in the invalid range from 49. For example, I have taken 47, 48, 49. You can take anything. So I have cut it classified. So what will be the test case for this particular algorithm, black box testing? So this input can be 48, 58, 500. So if you test by giving value 48, you are testing that it is less than 40 from 50, what will be the output? If you are taking 58, what will be the output? You are getting, if you are giving input 502, what will be the output? So you are testing all the possible solution, possible results. So this is the final result using the equivalent class partitioning. So next technique is known as boundary value analysis. So what actually happens in boundary value analysis? In equivalent class partitioning, there is a problem. You are not checking the boundary of equivalent partitioning. But sometimes what happens? Suppose there is a value, say in function you have written, say if a less than equal to b. For example, if the programmer mistakenly written forget to write the equal symbol, what will happen? Suppose if number is greater than equal to 50, then it's okay. Then if 14 up to 49, it will be okay. But if you, what will be the output at 50? Because equal symbol is not given. So that type of boundary of partition should be set. Because if there are three partitions, then in particular partition, what is the output? That is by mistakenly sometimes happens. So this type of solutions can be obtained by using the boundary value analysis. That's why it is known as the boundary, because generally equivalent class partitions need to check the boundary value analysis. So what is the definition? Boundary value analysis is a black box test case design technique to test representative boundary between two equivalent class partitions. It includes both valid and invalid boundaries. A boundary value is an input or output value on the border of equivalent partitions, which includes minimum and maximum values at inside and outside boundaries. So let us take one particular example. So for this boundary value analysis, let us take the earlier example, the same example. So the program which we write in the program, so they find out the even or odd number within the range from 50 to 500. So what will be the result? So we know that there are three partitions is sufficient to test the program. So here what will be the boundary value analysis? We have to check the boundary. So you check in the picture that there are 47, 48, 49 in one particular class. 50, 51 to 500 is another valid class. 51 to 503 is the invalid class. Now in earlier case, if you use the equivalent class partitioning, then 47 is also correct in both, 50 is also correct in 500. In boundary value analysis, what is the boundary between the left side and the middle one? That is the 49. 49 is the boundary between 50 and 14 and 50. So you have to check what will happen 49. And in valid class there are two boundaries, left boundary and right boundary. It is 50 and 500. In valid class the outer boundary is 49, in the invalid class 500, 501. So to test by using the boundary value analysis, you need 4 test cases: 49, 50, 500 and 501. 49, 50, 500, 501. That is we are checking all boundaries. So what is the final output or final test suite for this? 49, 50, 500, 500. That means this test suite will test each and every boundary of these three equivalent classes. So this is the technique of boundary value analysis. Hope you understand it. Next we'll discuss the different levels of testing. So in black box testing there are different levels. You can apply black box testing in unit testing level, integration testing level, system testing level, acceptance testing level. Now what is unit testing? Unit testing where all the units, components of the systems are tested independently, that means isolatedly. The purpose is to validate that each unit of the software performs as designed. In unit testing there is also, we will discuss in later classes what is unit testing, and when we will discuss in details in system testing. So for today's class, you remember that unit testing is to test each and every individual unit independently. So that is unit testing. For in black box testing, you have to design black box testing strategy for testing the unit testing also. After unit testing, integration testing. What is integration testing? You are testing individual units are combined and tested as a group, not the whole group. Suppose A and B are units, you combine it. Then what is the basic motto? That means integration testing will actually test the interfaces between any two modules or any three modules. So integration testing is a where individual units are combined and tested as a group. Its purpose is to determine the issues and errors in the interfaces among integrated components of the software. So it can be a top-down approach. There are different techniques we will discuss later on. Not today's class, in coming classes. Now, what is the next level? System testing. In system testing, the fully integrated system is tested. That is, fully developed system, that is a complete and fully integrated software is tested. Its purpose is to check whether the whole system meets the requirement or not. Here, there are 7 modules we combine all together. In unit testing, you have independently identify test 7 modules. In integration testing, first 1 and 2 are combined, tested, 1, 2 combination will be tested with 3 like this. But in system testing, all 7 modules are combined together and tested. So this is known as the system testing. If system testing is successful, then it is tested for acceptance testing. In acceptance testing, all whole system which is developed, which is successfully tested in system testing, is tested for acceptance. That means that is user level. In acceptance testing, the fully developed software is tested for end user acceptability. Its purpose is to check whether the whole system meets the user requirement or not. That means the final decision will be taken by the user whether that particular software will be acceptable or not. So there are 4 basically levels of black box testing. One is unit testing level, integration testing level, system testing level, and acceptance testing level. In details we will discuss later on when we will discuss debugging and different kind of testing techniques. Now we have to discuss different level of black box testing. Let us discuss different types of black box testing. So there are basically different types. Functional testing. Black box can be classified into functional testing, non-functional testing, and regression testing. These are the 3 types of black box testing. In functional testing, functional components are tested nowadays. That means if there are functions A, B, C, you have to test black box using black box testing or testing functions of A and B and C. So this is known as the functional testing. There are different type of more tools are available. For example, QTP, then Selenium, etc. These are the tools for black box functional testing. So functional testing is definition that it tests each and every function to verify whether it satisfies all functional requirements or not, which is specifying the user specification requirement. Now, what is the different? Next class is the non-functional testing techniques. In non-functional black box testing, here functions are not tested. Here, non-functional components are tested. Now, what are the different kind of non-functional testing? For example, performance issues, reliability, scalability. So, this type of stress testing. These are different kinds of testing which are non-functional, but those are related to the system. So this type of black box testing is known as non-functional testing. Now, what is the final testing type? Regression testing. When regression testing is required, when your software is either upgraded, when your system faces some errors and you have modified it, and let's check whether your errors is corrected or not. At that time regression testing is that. The definition is that regression testing is required if the system is changed or upgraded to fix some bugs or enhance performance. So how regression testing is done, we will discuss later on, but basically you need regression. In regression testing, suppose A system is there, you have upgraded to B, then after upgradation you have incorporated different function. We have to test using earlier test cases and check whether after upgradation all these things are going correctly or not. So this is the regression testing. So what are different types of black box testing? black box testing types: functional testing, non-functional testing, and regression testing. So today we discuss the definition of testing, different types of testing, different terms, bugs, errors, all these things. So hope you have enjoyed. In the next coming video we will discuss white box testing strategy. Hope you have enjoyed my video. If you have any comment, you can share it, comment in the comment boxes. If you like it, share and subscribe it. Thank you.